Welcome back to m253 Calculus 3 Cañada. In this video, we'll take a look at section 3.4. Motions in space. For this, we're going to start by studying velocity and acceleration. So the idea that we're given a position function, like r of t, a vector valued function, we can find the velocity by taking the first derivative and find the acceleration by taking the second derivative. We're also going to be able to take a look at the speed as the magnitude of the first derivative of your vector valued function. And we can easily apply this in 2 dimensions or in 3 dimensions. After we study some velocities and acceleration, we're going to take a look at components of an acceleration vector. If you have a plane curve, what we're interested in doing is we want to be able to write your acceleration vector as a linear combination of 2 other vectors that are going to be perpendicular to each other. Well, the natural 2 vectors to look at are the unit tangent vector and the unit normal vector. So we'll see that when we study the unit normal vector, it's going to be very related to the acceleration. We're also going to take a look at these as what's called the tangential and the normal components of your acceleration. Because we're dealing with the unit tangent and the unit normal vectors, we're really just going to rely on the lengths of these extended vectors to get our acceleration. And that is why they're called the tangential and normal components of your acceleration. After that, we're going to study projectiles. Projectiles are going to be sending things in the air given some gravity. So we're usually going to start off with the gravity, like our acceleration, and do a couple of integrals to get to the position. So with that, we're going to be able to look at things in 2 dimensions and also 3 dimensions. By studying the motion in space, we can figure out how high a particular projectile can go, how far a particular projectile can go, how much time in the air it's going to take, and a bunch of other types of questions that are related to the position or the velocity of these projectiles. Finally, we're going to take a peek at Kepler's law. Kepler has 3 laws that are going to be related to what we're studying, and all of them kind of revolve around the idea of an ellipse. It turns out that a planet's orbit around the sun is not in a circular way, but actually is in the shape of an ellipse. So these elliptical paths that we'll see we can study some calculus for them, like finding the areas within a particular path. And we're going to find relationships between our conic section ellipse and study this in the context of polar coordinates, and then somehow relate it to our vector valued functions. All right, that is the last section in chapter 3, and with that, I wish you good luck.